All right, calculus students, I wanted to hit you guys with something. In class the other day, I said go ahead and try to solve e to the x minus e to the negative x over 2 equals 1. And I hadn't made the video yet. I'm making it for you now. So what we're first off, we're going to do, we're going to multiply by 2 on both sides. And I get e to the x minus e to the negative x equals 2. Maybe we'll add, I should have done this all in one step. I don't like the e to the negative x, but e to the negative x times e to the x is e to the 0, which is 1. So if I multiply this through by e to the x now on both sides, I'm going to get e to the 2x minus 1 equals 2e to the x. And this is really e to the x squared. E to the 2x and e to the x squared are the same thing. I'm going to subtract the 2e to the x to the other side. And I have something like this. All right, so this is where the magic comes in. We're going to say u equals e to the x. So u squared equals e to the x squared, which is e to the 2x. And this equation turns into u squared minus 2u minus 1 equals 0. Now, this is a quadratic formula problem. You guys remember it as negative b plus or minus the square root of b squared minus 4ac over 2a. We're going to apply that here with u. U equals negative b, which is positive 2, plus or minus the square root of negative 2 squared, which is b squared, minus 4 times a, which is 1, times c, which is negative 1. And then we have it all over 2 times 1. When you clean this up, you will get 1 plus or minus 1/2 square root of 8. Or u equals 1 plus or minus square root of 2. So we didn't start with u, so we're not going to end with u. This actually has to equal e to the x. We're going to plug u back in. So u is e to the x. Remember, the graph for e to the x is greater than 0 for all x. So we got to make sure, see if any of these work. Square root of 2 is about 1.4. So 1 plus square root of 2 is about 2.4. 1 minus square root of 2 is about negative 0.4. So the minus 1 is out. That's out. We don't want that one. So we're only going to use that one. So we'll say e to the x equals 1 plus the square root of 2. And the way we deal with this is we can take the logarithm of both, natural log of both sides. And x comes down as an exponent, x ln of e, which equals 1, equals natural log of 1 plus square root of 2. So x equals the natural log of 1 plus the square root of 2. You can get a decimal answer for that. I'm just leaving it as is. I want to give you that problem. I also wanted to show you some where you think about maybe how some of the stuff is affected by limits. Let's take a look at another problem with limits. Let's take a look at limit as x approaches 0 of e to the cosecant x. Now, this might require you to plot it. And so I don't really remember what cosecant looks like, but I know it's opposite or it's related to sine. So if I plot the sine graph, I got this. And everywhere sine equals 0 is an asymptote. And cosecant is off of those graphs. They make hoops or parabolas leading away from the x equals 0 axis. And I didn't want, I'm sorry, I didn't want x going to 0. I want x going to 0 minus. So like this is a little confusing. I'm going to say u equals cosecant x. And so I want to translate my limits for x to limits of u. So as x approaches 0 to the minus side, what is u approaching? This is the 0, x equals 0 line. So from 0 minus, it's actually approaching negative infinity. The graph of cosecant x is approaching negative infinity. So I can rewrite this problem as the limit as x approaches negative infinity of e to the u. This doesn't actually cause any problems. We can just like look at what e to the negative infinity looks like, which is 0. The limit as x goes to negative infinity of e to the u is 0. So the limit as x goes to 0 minus of e to cosecant x equals 0 also. That's it for that video. Peace.